right, so the focus of this is dividing monomials from the same section as the last lesson. And again, you've been dividing monomials since you started learning about division, probably grade 3 again. And so if I look here, I'm dividing two monomials. One of them's negative, but negative 15 divided by 3, same as negative 5. I can also write this as negative 15 over 3, but it's all equivalent. And generally, I like this better. It's just a little bit faster, and we'll see this more and more. It's just a bit faster to write it out like that. But remember, these mean the exact same thing. So if one looks easier to you, go with it. But they mean the exact same thing. And so if I look at negative 15x divided by 3, this is the same as negative 15x all over 3. What does it equal? Well, I already know that negative 15 divided by 3 is 5 whole. Or sorry, negative 5. That's from the last question. And then I just have this x. So what do I do with the x? Well, this x here is not being, there's no other x's to divide it by. It's just an x in my numerator, so I just have an x here. And if I want, I could, it's not wrong to put it all over 1. I mean, especially if you look at the 15 over 3, especially if you think of reducing it to 5 over 1. But again, it's not wrong to leave it like that, unless you're saying that's the best way of writing it. Negative 5x over 1 is, while it's not wrong, it's simpler just to say negative 5x. And in general, we want to write it in the simplest form. And so lastly, x divided by x, which is the same as this. Well, anything divided by itself is 1. Unless x is the number 0, 0 divided by 0 doesn't equal anything. You can't divide by 0. Division by 0 doesn't make sense. You can't break things up into groups of no size at all. But aside from that, you divide any number by itself, you get 1. And so x divided by x is 1. And we tend, when we see something like this, we tend to just kind of cross them out, put little ones here, just to remind us that, all of that's the same as just 1 whole. As long as x is any number but 0, that's going to equal 1. And 1 is a pretty simple number. All right, so kind of building off these, let's just go straight to these in kind of fraction form. So again, looking at this, I would first focus on what negative 15 divided by 3 is, which is negative 5. And then my x divided by x, which again, I already said is the same as just 1. So I could say negative 5 times 1, but why not just say negative 5? Okay, so the next one. Again, negative 15 over 3 is negative 5. This time I have x squared divided by x. So what does that equal? Well, let's think of what x squared means. X squared means x times x divided by an x. We already know that x divided by x is the same as just 1 whole. Those cancel each other out. So if I think about it this way, I realize what's left. I had x times x in the numerator. I had just a single x in the denominator, but one of each of these canceled out. So all that's left is a single x in my numerator. And so in the end, it's just negative 5x. And since we see this sort of ideas a lot, we can kind of tend to speed this up by realizing that x squared divided by x, one of these x's cancels out. So I cross out the entire bottom x, and I just cross out the exponent. So there's still an x left, but now there's no longer an exponent of 2. It's now an exponent of 1, if you want. And so the last one of these examples. Again, negative 15 divided by 3. Let's divide my coefficients first. Notice how similar that is to the work we did in the last lesson with multiplying monomials, in which we usually multiply our coefficients first. We don't have to, but why not? And then let's look at my different variables. X squared divided by x. We already saw from before that one of those x's from the numerator and the denominator will cancel out, leaving us with just 1x left. And then with my y's, I have y squared divided by y. Well, the same idea. I have 2 y's in my numerator being multiplied to each other, a single y in the denominator. So one of those from each will cancel out. But there's still a single y left in my numerator. And again, I said there's a single y left in my numerator because you could imagine it as it all having a denominator of 1 now, especially if you look at 15 over 3 being reduced to 5 over 1. But again, if you have a denominator of 1, it's never in simplest form. Just that means the same thing and is more concise. All right, so with that said, kind of progressed from negative 15 divided by 3 to this last example, but they're all very, very similar. And so let's look at these last two similar still examples to kind of wrap things up. And so in general, for this first one here, I have nothing against the division symbol, but I like writing it as a fraction better. So again, I'll write it like this. It just helps if I write it down properly. And with that said, notice how similar this is. Negative 15 divided by 3 is negative 5. Here I have x divided by x cancels out entirely. So those x's are just completely canceled out, which is, I could just cross it out, put a little 1 for each, because x divided by x equals 1 over 1, or just 1 whole. But really, they just completely cancel each other out. And then with my y squared, I have y squared divided by y. So one of these y's cancels out. But there's still a y left in the numerator. So negative 5y. And the good thing as well about writing your division statements as a fraction is it makes it easier to see which of these factors cancel out. They're on top of each other. Whereas personally, I find it less readily easy to see what cancels out when you write it horizontally like this. But again, they're both all good. And so last one, enough of the 15 and 3's. First, I would go think about what 24 divided by negative 3 is. That's negative 8. Then look at my a variable. I have a squared here and nothing else in the denominator. So nothing's canceling out the a squared. So it's just a squared left. But with I have b cubed divided by b squared. So I have b times b times b in my numerator. I have b times b in my denominator. Those cancel out and make a 1. These cancel out and make a 1. So what's left? Just a single b in my numerator. And again, there's no denominator left. So all that's left is a single b. And as well, what we usually do to kind of speed it up is once I realize that I have more variables of b being repeatedly multiplied in the numerator, I just cancel out the entire denominator. Both of those are gone, and this 3 goes down to just power of 1. Really, really similar to the work from the last lesson in that we have lots of choices, but we tend to focus on the coefficients than individual variables. And when you're dividing by values, especially when dealing with variables, you tend to have lots of variables that cancel out, that simplify down.